All right, welcome to our new unit, Unit 11, which is on volume. Some of this is going to be fairly simplistic, and then other parts of it will be a little bit more exciting as we go through them. So to start with, though, we're going to look through some of the more challenging pieces of it, and then we'll get to the formulas, and then we'll apply it to some problems. So first, we can find some stuff that we're going to reference today in our workbooks from page 316 to page 320. And that's where I'm going to go for just a minute to talk about some of these formulas. Mainly, we're going to be looking about how to derive the formula for circumference of a circle and area of a circle for just a minute. That's the first piece of what we need to cover in the core. So this is on page 316, and it's finding the formula for the circumference. Now, in our last unit, in Unit 10, we know that the formula for the circumference is 2 times pi times the radius. And so what they're going to show us is a way that we could think about how to derive that formula. So that's how it starts. It says the circumference of the circle is 2 pi r, and the perimeter of a regular polygon inscribed in a circle gives an estimate of the circumference of a circle. So if we start with just our smallest regular polygon, a triangle, that wouldn't be very helpful. But if we keep adding more and more sides, it gets closer and closer to a circle. So that's what this next paragraph says. If we have a regular polygon with infinite number of sides, then we could have the exact value of the circumference of that circle. So to prove this numerically, we need a formula for perimeter of a regular polygon with n sides. So to do that, the perimeter of a regular polygon is found by multiplying the number of sides by the side length. So if we put that into variables, symbolically we could say that p, the perimeter, is equal to the number of the sides times by the side length. If we can find the value of any side length s, then we can find the perimeter with n sides. So then they kind of give us a hexagon here that says given a regular polygon with sides s and radius r, we can divide it into that many congruent triangles. So if this is a hexagon, then it's going to have 6 triangles. 6 sides will have 6 triangles. And each triangle has a hypotenuse of the radius. This is the hypotenuse of the triangle right here. And a base length of s. So here's the base length here of s, which also is the side length. If we construct a perpendicular bisector from the central angle to the base, then we can use some trig to help us with that. So they're going to construct this perpendicular bisector. And then we get to turn the page. So we'll see the picture, but now we only have half the triangle. So the other half of the triangle was right there. And remember, this used to be s because it was a whole side, but now it's just half of it. So now we're going to say that s is equal to 2x's because we split the triangle in half. So then we were trying to find this angle. So theta is equal to, we're going to use sine, so opposite over hypotenuse. Then we'd multiply, and they'd get s is equal to 2x, or s is equal to 2 times the radius. So this is when we times by r right here. That's what x would give me, which is double it, right? S was 2x's, so 2 times, and then they solved this for x and got r sine theta. So now we're going to go and put that in for our side. So this is kind of the formula that we're going to use. Okay, so the number of sides times 2 radius sine of theta. That's what this right here is. Okay, this is the important piece, and if you notice, it's right here. So if it's 3 sides, remember that wasn't very much like a triangle, and so it's not very much close to the formula of 2 pi r. But as we get bigger and bigger, so they go clear to 1,000, then we get closer and closer to 2 pi r. Now 2 times pi, if we just use 3.14, 2 times 3.14 would be that 6.28. So they're saying the closer and closer we go, the closer and closer we'll get to that 2 pi r, because 2 pi is that 6.28. So if you did 1,000,000, you'd get even closer to it. So that's one way to derive the circumference. Then when you turn the page to page 318, now they're going to talk about how to derive the area of a circle. So they're going to use a similar process. Now we know that the area of a circle, again, is pi r squared. And again, they're going to start with a polygon, a regular polygon, and they're going to put more and more sides so it gets closer and closer to a circle. So they say because a regular polygon with with n sides, a side length s can be divided into n isosceles triangles. So back to that same thing. This was a hexagon and it had 6 triangles. Then we can say that the area is equal to 1/2 the base times the height, because it's a triangle, times however many sides it has. Then again, they split the triangle, and again, they find that angle, and again, they say, oh, but now we're trying to find the altitude is adjacent to the angle, and so cosine now of theta will be a over r, because now we're trying to find the altitude. So then we can isolate that and say a is equal to r cosine theta. Okay, well, let's see where they're going with that. Let's turn the page. Then it says, okay, so then let's substitute that. By substituting these values into the formula, we get area is equal to, here's my base, times my height, and then they simplify it all out and they get this craziness, and I'll let you think through that a little bit. And then we can use this equation to show that as n increases, we're going to get closer and closer to 3.142. So again, here's this right here, right here. So then they do 3 sides, plugging all this stuff in for 360. So 3 sides would be right here, r squared, 3 sine of 60 cosine of 60. When it's 4, it's, and again, we're leaving the r, just r squared. Remember, we're trying to get to 3.14. And again, they get clear to 1,000. And they get to 1,000, they're getting closer and closer to 3.142. So a regular polygon with 1,000 sides is accurate to 4 decimal places for the approximation of the area being pi r squared. So with an infinite amount, we would get closer. Now, another way that I usually talk about when I use it in a general math class is that I talk about dividing that circle into smaller and smaller triangles. And the more smaller the triangles we get, the closer we get to the radius times the side length, right? This is 10, so this is still my radius, and I just stack my triangles every other one, and it gets smoother and smoother to where it will then be my radius times my number of sides. And then it continues on from there and says, so then the base of the parallelogram is half the circumference, so therefore base is equal to 1/2 2 pi r, that was the base, which would be pi times r, which is the radius. And so the area of a parallelogram, which we kind of already talked about, was base times height. The base was the circle, pi r, times the radius r, the height, giving us pi r squared. So kind of another way of looking at how you can find or derive the formula for the area of a circle. So if that went flying over your head, you can go ahead and read back through it again, and hopefully it will make maybe a little bit more sense, and you can kind of understand where those formulas kind of come from as we increase the number of sides. So today we are going to focus on just a couple of ones, and then as we go throughout each of the sections we will add a few more. So today we're going to talk about prisms in 11.1 and cylinders. Then in 11.2 we're going to talk about cones and pyramids, and then spheres will be 11.3. Now a prism is a 3-dimensional figure with 2 congruent parallel faces that are bases. A cylinder, again, is a 3-dimensional figure with parallel bases that are circles. So if the base is a circle, then we call it a cylinder. Also, maybe you think of it as a can. And those are the 2 that we're going to focus on today. Then in 11.2, we'll talk about a cone and a pyramid and what their definitions are. And then we'll finish it up with a sphere, and then we'll talk about scale factors in 11.4. Okay, so we're done almost with our workbook. There's one thing that our notes start out with, and that's Cavalieri's principle. And Cavalieri's principle has actually been moved to secondary 3, but I kind of just want to talk about it for a minute. I call it the slinky principle because it just talks about if 2 space figures have the same height and the same cross-sectional area at every level, then they're going to have the same volume. So they're saying that this picture right here, and this picture right here, and this picture right here will all have the same volume because they have the same area, same cross-sectional area at every level. So they'll all have the same volume. And they say the same thing can be said of a cylinder. They're going to have the same volume on a cylinder. And we're going to write that down now that we're in our notes. So if you'll go to the note packet, and Cavalieri's principle says that if 2 figures have the same height and also cross-sectional area. Cross-sectional area, then they'll have the same volume. And you'll hear that idea again when you get into Secondary 3 next year. So let's do first volume of a prism. So we know a prism has the same bases, so we're going to say the volume is the area of the base. That's why I'm going to call that a big B. Area of the, oh my goodness, I can't spell all of a sudden. The area of the base, and then times by the height. Now the area of the base can be different depending on what your prism looks like. You could have a base that is a square or a rectangle. And if it's a square or a rectangle, how do you find the base or the area of a square or rectangle? Well, you do length times width. So if the base is a square or rectangle, then you'll do your length times your width of your base. If it is a triangle, then it's 1/2 the base times the height. The base of the triangle, or the height, base times the height, and then take half of it. And then if the base is a circle, which we're going to talk about in just a moment down here when we talk about cylinder, remember the area of the circle, right here, base area is pi r squared. So if it's a rectangular prism, then we would say the volume is equal to the length times the width times the height, because this right here is the area by base. So this first little part is just about getting it set up into the formula and just getting your answer. I promise it's going to get more exciting again in a minute, but this first part's not too bad. So you're just going to do volume is, well, my base is 17 times 18. Okay, again, that's my base. And I'm going to times it by 4, which that is my height. And it's just a matter of calculating that on your calculator. So doing 17 times 18 times 4. And I don't know if you're going to be able to see my calculator right now. I forgot to flip it out, the lights out. So it might be a little bit hard to see. But hopefully you have your own and you're doing 17 times 18 and timesing by 4. And you get 1,224. And if I do centimeter times centimeter times centimeter, that's centimeter cubed. So on B, this time I have a parallelogram for my bases, but it's still going to be 13 times 20 times 10 for the height. Right, this is my height. And then again, I'll just multiply that. I get 2,600 yards cubed. Okay, so those are prisms. On your assignment, you'll see a triangular prism, so just make sure you do 1/2 base times height on the one that you see on your assignment that's a triangular prism. I'll have a triangle here and here, so that you'll be able to do that one. Okay, volume of a cylinder. Well, again, we're going to use that same idea that volume of any type of shape is equal to the area of the base times the height, right? This is the area of the base. But on a cylinder, my base is a circle, so the area of a circle is pi r squared, and then times by the height. So this is the one that I'm going to use when I see a cylinder. So on the first one, I've got volume is equal to pi. My radius, make sure it's radius, is 15 squared, because I'm doing the area, pi r squared, and then times by the height of 23. And then again, you just punch it in, and on these you'll round to the nearest hundredth. So again, hopefully you can kind of see my calculator. I apologize if not, but we've got our pi, our 15 squared, and then times by 23. and I get 16,257. And again, we'll round to the nearest hundredth, so 7.4. And then millimeters times millimeters times millimeters will make millimeters cubed. Now you certainly could stop the video for a minute and try B by yourself. I'm just going to quietly work on it while you work on it, and then we'll compare. Those numbers are a little hard to read. This is an 8, and this is a 30. All right, so I get for my answer, when I times those three things together, my pi multiplied by my radius, which was 8 squared, because it's pi r squared, and then times my height of 30. Okay, so that's pretty basic, and that's actually something that we work on in 7th grade math. But where you didn't take 7th grade math, you really didn't get that. So that's why we kind of review over that for just a moment. And then we're going to go to our application problems, which always bring a little bit more excitement. At first, we just have the same type of an example, except we don't have a picture to reference. So notice it says we have it will tell you what kind of thing, a cylindrical pitcher. And it's full of water. The pitcher's diameter is 8.4 and the height is 15. Find the volume. So it's a cylinder, so that means that volume is going to be pi r squared and then times by the height. So my volume will equal pi. Now we have to be careful. They said the diameter was 8.4. So divide my diameter by 2. That means my radius is going to be 4.2 squared. And then my height is 15. So again, I'll just go punch that into my calculator. I'll have my pi. Again, I apologize that you can't see it very well. 4.2 squared and 15. Oops, I think I have to press the times in between. Better safe than sorry. Oh, sorry about that. 831.27. Because remember, we're rounding to the nearest hundredth, centimeters cubed. B. Now they're going to change it up a little bit more. This time they say the volume of the cylinder is 615.8 cubic meters and its height is 4 meters. Find the length of the diameter of the cylinder. So now they're asking us to think a little bit more and not just plug it into a formula. It's still a cylinder, so I'm still going to use volume is equal to cylinder is pi r squared h, and you will have to have these all memorized. It won't be given, a reference sheet won't be given to you. You should know it's the area of the circle times the height, because you have 3 dimensions there. And they told me what it equaled, so they told me the volume, 615.8. Pi, I don't know the radius, but they did tell me the height was 4. So if I'm trying to find out the radius, I need to get rid of these two. They're both being multiplied, so I'm going to divide them by pi and by 4. So then that's going to give me, goodbye to my 4's and pi's, I'm going to have r squared equal to. Now we have to be careful here on our calculator when we do this calculation. So please follow along and watch how I type this into my calculator. If I want to multiply these two together, then I need to put that into a parenthesis. Or I can just do a double division is how I choose to deal with it. So I do 615.8. I divide it by pi, but I also need to divide it by 4. So I divide it by pi, and then I press divide again, 4. Because I not only need to divide by pi, but I also need to divide by 4. Don't do pi times 4, or it will do 615.8 divided by pi, and then it'll times that whole answer by 4, and we don't want that. So 615 divided by pi, and then do another divide by 4, because you need to have both things divided. That gives me, as for my answer, 49.00, so just 49. That's kind of nice. And I'll square root, and r will equal positive or negative 7, but we aren't going to have a negative radius, and so it will be 7 for my radius. Is that what they're asking me to find, though? No, they said, what is the diameter? So then I need to take 7 times 2 will give me my diameter equal to 14, and now I need my unit, meters. Okay, so that one was a little bit more exciting. Let's do our final last problem, which is the most exciting that we're going to get today. I'm going to zoom it in just a little bit so we can read it a little bit clearer. I apologize that I haven't done that sooner. It says Sally bought 2 cylindrical cartons of ice cream. That's kind of an interesting way to say how she bought 2 cartons of ice cream. I'm going to go buy 2 cylindrical cartons of ice cream today. One carton has a radius of 4 centimeters and a height of 8 centimeters, and the second carton has a radius of 8 centimeters and a height of 16 centimeters. Now, what do you notice about those two numbers? Do you see how they're double each other? Sally thought that since the dimensions were doubled, the volume of the big container should be twice as much as the little container. Is she correct? Well, it asks us to find the volume of both containers and then explain our answer. All right, so let's go find container 1. And that's what you'll need to do on your assignment as well. You'll have to show your work for each part of it. Remember, it's a cylindrical carton, so that means pi r squared h. And on the first one, we have pi, and her radius was 4, and the height was 8. So that would give me, again, I can times it out. When I multiply it out, I get 402.12 centimeters cubed. Now I could have also just done 4 squared, which is 16, times 8, and I could have left this as 128 pi for its exact, right? I just want to remember that for when I go to talk about whether it's doubled or not. So now container 2. So on container number 2, again, it's a cylindrical container, so volume, pi. Remember, the radius was double, and so was the height. And when I do that one, oops, sorry about that, making you dizzy, I get, give you a minute to punch that in. I get 3,216.99 centimeters cubed. Well, if it was to be doubled, 400 doubled should be 800. Is that 800? It is not. Now, if I just take this for a minute and do the exact, and I have 64, because that's what 8 squared is, times 16, this is 1,024 pi. So we know for sure that it's not. No, it is not doubled. What is it then? Rather, it is, how many times larger is it? Well, you can think of it 2 ways. You can just approximate 4 goes into 32 8 times, or if I have 128 and I'm at 1,024, 1,024 divided by 128, that is 8 times larger. It is 8 times larger. So let's think about this for just a minute. Why is it 8 times larger? Well, for container number 1, the radius was 4 squared, which was 16. And for container number 2, the radius was 8 squared, which was 64. So right there, that is 4 times larger. 16 to 64, that is, from 16 to 64, that's 4 times larger. And then if we have our height, the height was 8, and nothing happened there. And then the height changed to 16. So from 8 to 16, that's 2 times larger. And 4 times and 2 times larger will make that 8 times larger. So you're going to do a couple of problems and think about this idea, and the scale factor idea is where we're going to go throughout the unit, and then we'll put it and tie it all together once we get to section 11.4. Okay, good luck on your volume and on your questions about volume as you deal with first just some straight up problems and then as you deal with some fun story problems.